welcome to Integrated Science, and this is grade 8. So we've been looking at the topics human body, and topic 2 we looked at health, by now you should have looked at the environment, and also finished plants and animal cells. And looking at the time that we're in now, people must be doing materials and energy, or must have started. I'm sure some people have started, but we'll do a recap of materials and energy. This is the topic we are concentrating on today. Now, to bring you back to our grade 8 syllabus, what we've been doing under human body, you should be able to identify, or to be able to identify the main reproductive organs of the male and female. Here we looked at reproductive organs, so if you are revising, this is good. This is a good follow-up plan for you to be able to revise your grade 8 work, and by now you should be able to reach up to energy, sorry, up to materials and energy. So we looked at reproductive organs, and you should be able to also know fertilization and puberty. Okay. Health, you should be able to identify the main 7 nutrients, and also clinic cards, and dietary needs for different people. Okay, dietary needs for different people. Here we looked at the dietary needs of a lactating mother, the dietary needs of a working man, the dietary needs of a baby, and also the dietary needs of the aged. We looked at the clinic card, which you are supposed to be able to identify just by looking at it, and you're supposed to be able to put the things where they're supposed to be on a clinic card. When you look at a clinic card, you're supposed to identify where the age is supposed to be, the information that is found on a clinic card, where the weight of the child is found, the months, the section that describes the months, and the section that describes the weight, where arrows show what, when the baby is not doing well and when the baby is healthy. On environment, we looked at pollution. And of course, we should be able to describe the 3 types of pollution, which are water, land, and air. This is one of the easiest topics in grade 8. It has not much of complicated work. Everything about pollution we are able to see right from our homes to our schools. There is pollution everywhere in our country. There is pollution everywhere we go, land, air, and water, and you are able to describe, you are able to identify. So this is one of the easiest topics. Plants and animal cells we looked at, the microscope. Looking at the microscope, you're able to define what the term microscope means. We said this is a device that magnifies objects that we cannot see with our naked eye. You should also be able to identify the parts of the microscope and also state their functions. You should be able to state the functions of the parts of the microscope. We have the base. When we looked at a microscope, I remember bringing a microscope here, and you have the base, you have all the parts of the microscope. Be able to revise all that work. Be able to identify a plant cell using a microscope. We did the plant cell, and also animal cell. Here you should be able to also differentiate between the plant cell and the animal cell. After that, we also did plant responses. Plant responses are here, and also plant nutrients. Now, when we look at plant nutrients, plants produce their own nutrients. For example, oxygen, nitrogen, hydrogen, phosphorus, sodium, calcium, magnesium, those are produced by plants. But if the plant cannot produce sufficient nutrients, or if we want to produce more yield than the one that the plant is producing, we usually aid that yield, or we usually aid the plant to grow well and faster using fertilizers. So on plant nutrients, that's why we also discuss fertilizers, and there are two types of fertilizers that we looked at. There's an organic fertilizer and an inorganic fertilizer. So you should be able to identify or to explain the advantages of organic fertilizers and the disadvantages of organic fertilizers, where at the same time you should also be able to explain disadvantages and advantages of inorganic fertilizers. I've said there are two types of fertilizers. So these are the points you need to look at if you are revising and you want to be up to speed with what a grade 8 pupil is supposed to know up to date. You're supposed to know these 4 topics and be able to explain clearly the subtopics that I've given on the board. So today I'm going to look at materials and energy. Materials and energy is our topic for the day. We're going to start it from 1 because not everyone can remember everything that we've done in materials. So all materials are made of matter. All materials are made of matter. What is a material? Okay, what is a material? What is a material? I have paper here. It's a material. I have the board here. All these are materials, right? So I'm saying all materials are made of matter. Okay? Now, this new term that I've brought, what is matter? What is matter? Matter is anything that has weight and occupies space. Matter is anything that has weight and occupies space. My marker has weight. That is why I'm able to carry it and feel that there is something in my hand. It has weight. When I place it here, it is occupying space. This duster is occupying space. So because it is occupying this particular space of the table, I will say that it has mass and occupies space. Therefore, it qualifies to be matter. Okay? It qualifies to be matter. This is, all materials are made of matter. So this is made of matter because it, okay? So matter is anything that has weight and occupies space. Okay, matter is anything that has space and occupies weight. Now this particular matter can be identified in 3 forms. We have 3 forms of matter: solid, liquid, and gas. Okay, solid, liquid, and gas. Okay, we have 3 forms of matter: solid, liquid, and gas. So this is a solid. Okay, I do not have water here with me. We all know that water is a liquid. All the juices that we drink, everything that we see in a flowing form, obviously we'll talk about the particles later, but we all know that we can identify a liquid by looking at it. Oh, sorry, I think there's methylated spirit here. Okay, so this is a liquid. These are solids. okay? Gas is what we are not able to see, but whatever is in this room aside our solids and our liquids is gas. Everything you can see in the air is gas, okay? So we know that matter can be in three forms: solid, liquid, and gas. And we can identify these three forms using two properties. These are volume and space. These are volume and space. So volume, okay, and space are the quantities that help us to identify matter. Volume and space are the quantities that help us to identify what state matter is in, or what form matter is in, either liquid, solid, or gas. So volume is the amount of space occupied by matter. The amount of space occupied by matter. Okay, volume is the amount of space occupied by matter. And obviously, we know that this property, shape, okay, does not change. The shape does not change in any kind of temperature. So whether it's hot or cold, shape will not change. Therefore, volume being the amount of space occupied by matter is what will help us define what form our matter is in. And obviously this will change what we call another property that we are calling density. If the volume of something is changed in the form that it is in, it will also affect the density. Density is the amount of matter per unit volume. Okay, now let's understand this. If I am saying that volume is the space occupied by matter, and I've said that this is a material, meaning it contains matter. Volume is the space occupied by matter. So obviously the volume will be this space that my duster is occupying. The space that my duster is occupying is the volume. And now I'm saying that density is the amount of matter per unit volume. So the amount of matter found in this particular volume is what I'm calling density. The amount of matter in the space occupied by my duster is what I'm calling density. Let's not miss this. You can get a cup, you can get anything, place it on a particular space. Whatever space your object is occupying, you will call it volume. Call the matter found on that particular space density, and you're good to go. So volume is the space occupied by matter, whereas density is the amount of matter per unit volume. Now, matter is made up of particles called atoms. I'm bringing in another term, atoms. What is an atom? An atom is a basic unit of matter. Okay? So this also goes to say that matter is made up of atoms, because an atom is a building block of matter, or it is a basic unit. When I say basic unit, it means a building block. When we are building this room, or when you're building your house, if you've seen people building, builders build using blocks. So every block contributes to the building of whatever estate it is. It may be a house, it may be a building, it may be an estate, it may be a flat, it may be a big apartment. But every little block that was placed on that house contributed to its building. So those little blocks we are calling as atoms, and those blocks are what are going to form our matter. So when I say an atom is a basic unit, it means that it is one of those units that were put together to form matter, or it is one of those blocks that were put together to form that particular building, which in this case is matter. I am comparing atom and matter to block and building. So when you look at an atom and matter, you think of it as the atom being those small blocks that will make up a house, and the atom in this case will make up the matter. Okay, so an atom is a building, is the basic unit of matter, or it is a building block of matter. Now, it is the smallest unit of matter. It is the smallest unit of matter which when put together will form matter. Okay, so matter does not come about without atoms. Let's be clear on that. I hope we are clear. Now, these atoms when put together form an element. So atoms of the same kind form an element. So because I'm saying atoms of the same kind, it means that there are also atoms of different kinds. So when you hear the term atom, do not assume that there is one atom on the Earth's surface. We have many different atoms. I repeat, we have many kinds of atoms, but atoms of the same kind are called elements. For example, okay, aluminium atoms will form aluminium. Aluminium atoms will form aluminium. Most atoms do not occur separately. They usually occur put together with other atoms. And when one atom is combined with another atom, we call them diatomic molecules. Or if two atoms are put together, we call them a molecule. Most atoms do not occur individually. They occur bound chemically together. When I say chemically, I mean using chemical bonds, or using bonds of atoms. We call atom bonding, we call it chemical bonding. So chemical bonds put atoms together to form what we call a molecule. So a molecule is a group of chemically bound atoms. Okay, a molecule is a group of chemically bound atoms. For example, oxygen. Okay, now in the case of oxygen, this is what I'm talking about. This is one oxygen atom and another oxygen atom that have been chemically bound together. Now you can see that both atoms, this is one atom of an element and this is another atom of an element to form a molecule of oxygen. This is the same kind of atom, so I will call this a diatomic molecule, because it is bound by the same kind of atom. Because it is bound by the same kind of atom, I will call it a diatomic molecule. The other kind of molecule is called a chemical compound. Okay, so this is oxygen. Get familiar with these terms. We'll look at the elements in the next lesson. And this is water. So when you are asked for the components found in oxygen, it's 2 oxygen atoms. In water you find 1 hydrogen atom and 2 oxygen atoms. So water is also formed by 2 different kinds of elements, but as you can see, this oxygen is the same. The only one that is coming up to form the 2 different kinds is hydrogen. So this one is called a chemical compound. Another chemical compound is carbon dioxide. which is also a combination of carbon and 2 oxygen atoms. It is a combination of carbon and 2 oxygen atoms, and we call it carbon dioxide. Okay, so now, how are these atoms put together? How are these atoms, how am I forming my oxygen? Oxygen is CO2. Oh, sorry, oxygen is O2, meaning that it's 2 atoms bound together. Okay, what is the basic structure of an atom? Let us look at the basic structure of an atom. We have looked at the components of matter. Components of matter, we have said that the building blocks of matter are atoms. The building blocks of matter are atoms, and matter is anything that has weight and occupies space. Then we say that matter can be seen in 3 forms, and we are able to identify the forms using shape and volume. Now, the shape doesn't change, so therefore volume is what determines the kind of state that matter is in. And I said that there are 3 states: liquid, solid, and gas. Volume is the space occupied by matter. Is the space occupied by matter. And density is the matter per unit volume. Is the amount of matter or the quantity of matter found in 1 unit of volume. Okay, so now let us look at the basic unit of an atom. Sorry, the basic structure of an atom. Okay, so an atom consists of a nucleus and what we call shells around it, or electronic levels around it. So if this is our nucleus, these are our electronic levels or our shells. Okay, so the nucleus of an atom consists of 2 subatomic particles. In the nucleus of an atom we find 2 subatomic particles. These are protons and neutrons. In the nucleus protons and neutrons. Okay, so protons are positively charged, subatomic particles, and these have a mass almost equal to that of neutrons. Neutrons are neutrally charged, or they are neutral, meaning that they do not have a charge. By charge I mean electric charge. So you've seen that in when we looked at batteries, or in grade 7 you might have looked at a battery and you said that one end of a battery is positively charged while the other is negatively charged. These are the charges I'm looking at. These are the electronic charges I'm looking at. So a proton is positively charged, whereas a neutron is neutral with no charge. Okay, and these are found in the nucleus of an atom. Okay, and these are the electronic levels or the shells. Okay, so in the shells we find electrons. And electrons are negatively charged subatomic molecules, particles rather, negatively charged subatomic particles. When I say subatomic, I simply mean that these are the contents of an atom. So if I say sub-woman, it means that these are things that are part of me and they are sub-woman particles. They are found in me. So subatomic particles are small atomic particles found inside the atom. Okay, so it's a negatively charged subatomic particle whose mass is equal to that of a proton. I said protons are also almost equal to the mass of the neutrons, although neutrons are found to be slightly higher in mass than a proton. So you expect that if this is 11 grams, this will also be 11 grams or maybe 11.1 or 2 grams, because they are slightly higher in mass than a proton. So now, how do we fit? How do we know where or how many electrons are found in the shells and how many protons and neutrons are found in the nucleus of an atom? How do we know where or how many electrons are found in a particular in the shells of an atom and how many protons and neutrons are found in the nucleus? We have different kinds of atoms and all atoms have different numbers. They have different number of electrons, neutrons and protons. Okay, so let's look at carbon. Let us look at carbon. Before we look at the periodic table, where you'll be able to identify or where you'll be able to see from how many electrons are found in a particular atom, I'll first give you carbon to just show you where you're supposed to put neutrons, where you're supposed to put protons, and where you are supposed to put electrons. So carbon has 6 electrons. Okay. So, if this is our nucleus, we expect that the number of neutrons and protons is found in the nucleus. Now, how do I place the 6 electrons in the shells? The first electronic level. This one is the first electronic level. This one is the second. And this one is the third. Okay? So, these electronic levels have rules of fitting electrons. The first level, you only fit 2 electrons. It cannot contain more than 2 electrons. In the second one, we fit 3 electrons. Okay? Oh, sorry. 8 electrons. And in the third one, 8 electrons. So starting from the second up to your 5th, 4th, 6th or 7th, depending on what atom you are looking at, you put 8 electrons in each shell. So the number of shells will be determined by the number of electrons. So in my case, I have carbon and it has 6 electrons, and I just said that the number of electronic levels or the number of shells is determined by the number of electrons. How many shells do you expect our carbon atom to have if it has 6 electrons? Obviously, our first shell or electronic level will have 2 electrons. Okay, so from 6, we've placed the first 2. We obviously are left with 4. All the 4 electrons will fit in the second electronic level because it can occupy up to 8. But since we have 4, all of them will fit. And therefore, you can say that a carbon atom consists of 2 electronic levels, or there are 2 shells in a carbon atom. There are 2 shells in a carbon atom because all the electrons fit, the first 2 electrons fit in the first electronic level, and the second electronic level will occupy all the 4 electrons. Even if carbon had 8 electrons, they would still fit, because the remaining 2 from the second level would have been occupied in the second one. Let's take, for instance, oxygen. Let's take, for instance, oxygen. Okay? Okay. Oxygen has 8 electrons. Okay. So in our nucleus we have protons and neutrons. First electronic level we have 1 and 2. We're remaining with 6. All the 6 will enter our second electronic level, because it can even hold up to 8, but because we have 6 remaining, we'll put them all in the second electronic level. So like carbon, oxygen also has 2 electronic levels. Just like carbon, oxygen will only consist of 2 electronic levels. So for now, I'll leave you with homework, or I'll leave you with something to do. I'll leave you with a task. Ask for any atom and atomic number. Sorry, I forgot to mention that the number of electrons found in an atom is also called the atomic number. So the number of electrons found in an atom is called the atomic number. So ask for any atom of an element. Your guardian or your family can, because we have not yet looked at the periodic table. I don't expect most of you to know these elements and atoms, but you can ask any guardian for any atom. What atom do you know? What atom of an element? Can you tell me? They will give you an element. They may give you magnesium, helium, hydrogen, fluorine. There are many atoms, calcium, aluminium, all those that I've mentioned and more, and ask them to give you the atomic number or the number of electrons. See how you are going to fill in the electrons in the shells following the rules of electronic configuration. Having done that, find out the number of electronic levels or shells found in each of the atoms you are going to get. So for now, it's bye till next time. Thank you.